Poisson distribution is also referred to as discrete probability distribution, which expresses the probability of a given number of events occurring in a fixed time interval. Conditions to apply Poisson distribution are: number one, the data must be discrete. Number two, the expectation of outcomes in an interval is constant. And number three, mean is equals to variance. Thus, Poisson distribution is expressed as X is a Poisson distribution, lambda, where lambda is equals to mean is equals to variance. मैं एक बार फिर repeat कर रहा हूँ. Poisson distribution is also referred to as discrete probability distribution, which expresses the probability of a given number of events occurring in a fixed time interval. The conditions to apply Poisson distribution are: number one, the data must be discrete. Number two, the expectation of outcomes in an interval is constant. Number three, mean is equal to variance. And thus the Poisson distribution is expressed as X is a Poisson distribution with its parameter as lambda, where lambda is equal to mean is equal to variance. क्योंकि Poisson distribution में mean और variance same होता है. Formula to calculate probability using Poisson distribution is E minus lambda, lambda की power n over n factorial, where lambda is the parameter where mean is equal to variance and n is the number of times the concerned data is occurring. Where n is the average number of times the favorable outcome occurs within fixed interval. So the first example is a help desk receives telephone calls at a rate of 2 per minute. Interval of time 1 minute दे दिया और 1 मिनट में 2 कॉल्स आ रही हैं. सो इसका मतलब ये हुआ X is a Poisson distribution and the parameter lambda is 2. ठीक है. So the first part of the question is exactly one call is received. So E minus lambda, lambda की power n over n factorial, E minus 2, 2 की power 1 upon 1 factorial. Please use the calculator. E minus 2 into 2 upon 1 factorial. 0.271. Correct to 3 significant figures. The second part of the question is at most 3 calls. ज्यादा से ज्यादा 3 कॉल्स आएंगे. ज्यादा से ज्यादा 3 कॉल्स का मतलब है 0, 1, 2 and 3. At most 3 calls. Agree? So E minus 2, 2 की पावर 0 over 0 factorial plus E minus 2, 2 की पावर 1 over 1 factorial plus E minus 2, 2 square upon 2 factorial plus E minus 2, 2 की पावर क्यूब अपॉन 3 फैक्टोरियल. काइंडली एक एक का आंसर निकालिए. पहला वाला है 0.135, दूसरा वाला है 0.271, तीसरा वाला 0.271 ही आ रहा है, चौथा वाला 0.1804. Final answer is 0.857. At least one call is received. At least one call is received means 1 या 1 से ज्यादा. 1 या 1 से ज्यादा का मतलब है 1 minus probability of 0 is at least 1. So 1 minus probability of 0 is 0.135. 0.865. प्लीज अगली एग्जांपल देखिए. A help desk receives telephone calls at a rate of 2 per minute. ठीक है. 2 per minute का मतलब है lambda 2 हो गया. Are you all with me? Calculate the probability in a 5-minute duration. ठीक है. नोट लिखिए. If the interval in Poisson distribution is changed, it will directly impact lambda and the number of times the interval is changed comma the lambda will be multiplied by the same number of times. इसका मतलब ये हुआ कि lambda initially 2 per minute था. the probability that in a 5-minute duration, तो टाइम इंटरवल 5 टाइम्स हो गया है, राइट. पहले पर मिनट था, 5 टाइम्स हो गया. तो x is a Poisson distribution, lambda will be multiplied by 5. So x is a Poisson distribution, lambda becomes. Agree? Now the first part is exactly 8. Probability of x is equals to 8. So e minus lambda, lambda की power n over n factorial, that is e minus 10, 10 की power 8 upon 8 factorial. More than 2 calls means probability of x is greater than 2. Greater than 2 is same as 1 minus probability of 0, probability of 1 and probability of 2. 1 minus e minus 10, 10 power 0, 0 factorial plus e minus 10, 10 power 1 over 1 factorial plus e minus 10, 10 power 1, 10 power 2 over 2 factorial. 0 point quadra 0 454 plus 0.000 454 plus 0.00227, 0.997. सब हेडिंग डालें. Conversion of binomial distribution to Poisson distribution. प्लीज याद करें, हमने एएस लेवल में सीखा था कन्वर्जन ऑफ बाइनोमियल टू नॉर्मल. तो बाइनोमियल जिस तरह नॉर्मल में कन्वर्ट हो सकता है, इसी तरह बाइनोमियल पॉसॉन में भी कन्वर्ट हो सकता है, लेकिन उसकी कुछ कंडीशंस होती हैं. ठीक है, वो क्या कंडीशंस हैं? इफ x is a binomial distribution n comma p, it can approximately be converted to Poisson distribution lambda if number 1 n is greater than 50, number 2 np is less than 5. If both these conditions are fulfilled, binomial distribution can approximately be converted to Poisson distribution. When binomial distribution is converted to Poisson distribution, there is no need to apply continuity correction because both binomial and Poisson are discrete. तो मैं जल्दी से एक क्विक कंपैरिजन कर लेता हूं कि जब x बाइनोमियल डिस्ट्रीब्यूशन है n, p, it can approximately be converted to Poisson distribution lambda when n is greater than 50, np is less than 5. Whereas x is a binomial distribution, n, p can be converted to normal distribution np, npq when n was greater than 30, np was greater than 5, nq was greater than 5. Agree? So इस वाली कंडीशन में, जो पहली वाली कंडीशन है, बाइनोमियल डिस्ट्रीब्यूशन can approximately be converted to normal distribution without applying continuity correction. Agreed? And obviously यहाँ पे जो लैम्डा है वो np के बराबर है. So Poisson distribution is NP, क्योंकि NP मीन होता है, अग्री, और Poisson डिस्ट्रीब्यूशन में मीन ही वेरिएंस होता है, तो कोई मसला नहीं है. इधर binomial distribution can approximately be converted to normal distribution. यहाँ पे आई एम सॉरी, Poisson लिखना था, मैंने गलती से नॉर्मल लिख दिया. Binomial distribution can approximately be converted to Poisson distribution without applying continuity correction, and binomial distribution can approximately be converted to normal distribution, but continuity correction will be applied because we are converting discrete data to continuous data. बात क्लियर है सबको? मैं एक दफा जल्दी से रिकैप दोबारा कर देता हूं. X is a binomial distribution n comma p where n is greater than 50 and np is less than 5, can approximately be converted to Poisson distribution where lambda is np. So Poisson distribution is np because np is mean and variance, दोनों बराबर होता है. Binomial distribution can approximately be converted to Poisson distribution without applying continuity correction because both binomial distribution and Poisson distribution are discrete. Whereas X, which is a binomial distribution n comma p, can approximately be converted to normal distribution np comma npq. Np is mu, npq is variance. When n is greater than 30, np is greater than 5, nq is greater than 5. So binomial distribution can approximately be converted to normal distribution, but continuity correction will be applied because we are converting discrete data into continuous data. So a company produces electrical components. The proportion of faulty components is 0.4%. Henry buys box of 1000 electrical components. Find the probability more than 5 components are faulty. अगर इसको बाइनोमियल से करने लगेंगे तो बड़ा लंबा प्रोसेस हो जाएगा. हम चेक करें, n 1000 है which is greater than 50. np 1000 into 0.004 is 4 which is less than 5. Since both the conditions are being met, I can safely say that X is a Poisson distribution. Lambda is NP, which is 4. Are you all with me? And we need to find the probability of X is greater than 5. So 1 minus probability of 0, 1, 2, 3, 4, and 5. Is everyone following me? So 1 minus e minus 4, 4 की power 0 upon 0 factorial. E minus 4, 4 की power 1 upon 1 factorial. E minus 4, 4 square upon 2 factorial. E minus 4, 4 cube upon 3 factorial. E minus 4, 4 की power 4 upon 4 factorial. E minus 4, 4 की power 5 upon 5 factorial. 1 minus 0.0183 plus 0.0733. प्लीज साथ साथ कंफर्म करते रहिए. 0.147, 0.195, ये भी 0.195, 0.156. 1 minus all this is 0.215. Next concept is conversion of Poisson distribution to normal distribution. Poisson distribution can approximately be converted to normal distribution if lambda is greater than 15. And in this case, if x is a Poisson distribution 15 or greater than 15, it will approximately be converted to normal distribution mu comma variance. And I hope आप सबको याद है कि Poisson distribution में lambda is equal to mu is equal to variance होता था. Therefore, normal distribution will be lambda comma lambda. Are you all with me? Since Poisson distribution is discrete and normal distribution is continuous, therefore, whenever we will convert Poisson distribution to normal distribution, we will apply continuity correction. जल्दी से क्विक रिकैप करवाता हूं. रूल्स ऑफ कंटिन्यूटी करेक्शन का probability of x is less than a will become probability of x is less than a minus 0.5. मैंने पूरा डिटेल में ऑलरेडी समझाया हुआ है, इसलिए सिर्फ रूल्स यहाँ पे स्टेट कर रहा हूँ. Probability of x is less or equals to a will become probability of x is less than a plus 0.5. Probability of x is greater than a will become probability of x is greater or equals to a plus 0.5. Probability of x is greater or equals to a will become probability of x is greater or equals to a minus 0.5. And probability of x is equals to a will become probability of x that lies between a minus 0.5 and a plus 0.5 not inclusive. These are the 5 rules of continuity correction that needs to be remembered whenever we are converting binomial to normal or Poisson to normal. ठीक है जी. तो जब कभी लैम्डा 15 से बड़ा होगा, Poisson distribution will approximately be converted to normal distribution in such a manner that lambda will be mu and lambda will be variance. So normal distribution will be lambda comma lambda, and we will have to apply continuity correction. An observer observes that turtle lays eggs on average 60 eggs on each nest following Poisson distribution. So X is a Poisson distribution 60. Please note कर लें lambda is 60 which is greater than 15. Therefore X is a Poisson distribution 60 which will approximately be converted to normal distribution 60 comma 60. First part of the question is probability of X is equals to 50. हम क्या करेंगे? We will apply continuity correction. We will apply CC. So probability of X lies between 49.5 inclusive, 50.5 not inclusive. We will apply normal distribution rules. That is 49.5 minus 60 upon under root of 60 and 50.5 minus 60 upon under root of 60. Calculator खोलें. 49.5 minus 60 divided by under root of 60 is minus 1.356. 50.5 minus 60 divided by under root 60 is minus 1.226. Are you all with me? याद करें normal distribution. Minus 1.356 minus 1.226 के बीच में लाई कर रहा है. Yes or no? Which means phi of minus 1.226 minus phi of minus 1.356. Are you all with me? Which is 1 minus phi of 1.226 minus 1 minus phi of 1.356. So this will become phi of 1.356 minus phi of 1.266. Please normal distribution apply करें. Read करें Z table. Read किया Z table? बताएं. 0.89. Final answer 0.0152. Probability of X is greater than 74. अगर greater than 74 है तो मैं continuity correction लगा के greater or equal to 74.5 बनाऊंगा. Z is greater or equal to 74.5 minus 60 upon under root of 60. Z is greater or equals to 1.872. Greater or equal to 1.872 means 1 minus phi of 1.872. Please read the Z table. 1.0.99694. So the final answer is 0.0306. Do you all agree? Do you all agree? इसके बाद at most 40 eggs बोल रहा है. At most 40 eggs means probability of X is less or equals to 40. So probability of less or equal to 40 means apply continuity correction. X is less than 40.5. So Z is less than 40.5 minus 60 upon under root of 60. Probability of Z is less than -2.517। लेस का मतलब है और माइनस, और लेस का मतलब है 1 - 5 ऑफ 2.517। डू यू ऑल अग्री? रीड द जी टेबल, बताइए 5 ऑफ 2.517 कितना होता है? 0.9941। So the final answer is 0.005। अब हमने क्या क्या चीजें करी? पहली बात हमने ये डिस्कस करी कि जब किसी फिक्स्ड इंटरवल के अंदर एक फिक्स्ड प्रोपोर्शन डिस्क्रीट रैंडम वेरिएबल्स के अंदर होता है अकरेंस का चांस, तो हम पॉसॉन डिस्ट्रीब्यूशन लगाते हैं जिसका पैरामीटर लैम्डा होता है, जहां पे लैम्डा मीन और वेरिएंस के बराबर होता है। ठीक। दूसरी बात हमने ये सीखी कि अगर इंटरवल चेंज होगा तो उसी प्रोपोर्शन के हिसाब से लैम्डा भी चेंज होगा। ठीक है, तो डबल इंटरवल होगा तो लैम्डा मल्टीप्लाई बाय 2 हो जाएगा, 5 टाइम्स इंटरवल होगा तो लैम्डा 5 टाइम्स मल्टीप्लाई हो जाएगा। तो जितना भी इंटरवल मल्टीप्लाई होगा उतने टाइम्स वो मल्टीप्लाई हो जाएगा। फिर हमने सीखा कि अगर x बाइनोमियल डिस्ट्रीब्यूशन है n p और n ग्रेटर देन 50 है, np लेस देन 5 है, तो ऐसा बाइनोमियल डिस्ट्रीब्यूशन कैन अप्रोक्सीमेटली बी कन्वर्टेड टू पॉसॉन डिस्ट्रीब्यूशन जिसका पैरामीटर np होगा। अग्री? एंड क्योंकि बाइनोमियल भी डिस्क्रीट है, पॉसॉन भी डिस्क्रीट है, तो कंटिन्यूटी करेक्शन लगाने की जरूरत नहीं है। अग्रीड? और आखिरी बात हमने ये सीखी कि अगर x इज अ पॉसॉन डिस्ट्रीब्यूशन such that lambda is greater than 15, then it can approximately be converted to normal distribution lambda comma lambda and apply continuity correction क्योंकि डिस्क्रीट से रैंडम में कन्वर्ट हो रहा है। The number of complaints at a customer service is modeled by Poisson distribution with a mean of 6 complaints per minute. Part 1. Calculate the probability that in a given minute there will be 9 complaints, 3 or fewer complaints, at least 1 complaint, part 2. Calculate the probability that in 2-minute interval there will be 10 complaints. सबसे पहली चीज हमने रियलाइज करनी है कि x is a Poisson distribution, lambda is 6. Are you all with me? So जो फर्स्ट पार्ट है जिसमें एग्जैक्टली 9 कंप्लेंट्स हैं, e - 6, 6 की पावर 9 over 9 factorial, 0.00688। 0.0688। 3 और फ्यूअर कंप्लेंट्स का मतलब है प्रोबेबिलिटी ऑफ 0, प्रोबेबिलिटी ऑफ 1, प्रोबेबिलिटी ऑफ 2, प्रोबेबिलिटी ऑफ 3। आर यू ऑल विद मी? यही फॉर्मूला लगा देंगे। e माइनस 6, 6 की पावर 0, 0 फैक्टोरियल, प्लस e की पावर माइनस 6, 6 की पावर 1, 1 फैक्टोरियल, e की पावर माइनस 6, 6 2 अपॉन 2 फैक्टोरियल, e की पावर माइनस 6, 6 की पावर 3 अपॉन 3 फैक्टोरियल, 0.151। एटलीस्ट वन कंप्लेंट, एटलीस्ट वन कंप्लेंट का मतलब है 1 या 1 से ज्यादा, यानी कि 1 माइनस प्रोबेबिलिटी ऑफ 0, 1 माइनस e माइनस 6, 6 की पावर 0 अपॉन 0 फैक्टोरियल, 0.998। आर यू ऑल विद मी? डू यू ऑल एग्री? ठीक है। पार्ट 2, द प्रोबेबिलिटी, क्या है, द प्रोबेबिलिटी दैट इन 2 मिनट इंटरवल x इज अ पॉसॉन डिस्ट्रीब्यूशन, लैम्डा इज 6। 2 मिनट इंटरवल में क्या हो जाएगा, 6 इंटू 2, x इज अ पॉसॉन डिस्ट्रीब्यूशन 12। 12 15 से छोटा है। अगर ये 15 से बड़ा बन जाता तो मुझे नॉर्मल डिस्ट्रीब्यूशन में कन्वर्ट करना पड़ता। 15 से छोटा है तो मतलब पॉसॉन ही रहेगा। आर यू ऑल अंडरस्टैंडिंग द डिफरेंस बिटवीन ऑल द कॉन्सेप्ट्स? सो दिस विल बिकम probability of x is equal to 10, तो e minus 12, 12 की पावर 10 over 10 factorial, 0.105। Calculate the probability that in 3 minute interval there will be fewer than 12 complaints. So x is a Poisson distribution, 6 into 3. X is a Poisson distribution, 18. Agreed? Lambda is 18, which is greater than 15. Hence, x, which is a Poisson distribution 18, will now be converted to normal distribution 18, 18. हमें चाहिए probability of x is less than 12. Apply continuity correction. So probability of x is less or equals to, sorry, less than 11.5. So z will be 11.5 minus 18 upon under root of 18. Sorry, negative 1.532, which is 1 minus 5 of 1.532. Z table read करें, 5 of 1.532 बताएं, 0.9372, 0.0628. A machine is known to produce defective components at random and independently of each other, on average 0.24 times in a production of 500 components. X is a binomial distribution, 500 comma 0.0024. 0.24% का मतलब है 0.024. So n is 500, which is greater than 50. np is 500 into 0.0024, which is 1 point, which is less than 5. So x, which is a binomial distribution, 500 comma 0.0024, can approximately be converted to Poisson distribution with lambda 1.2. तो हम क्या करेंगे, probability of x at most 3, at most 3 का मतलब है ज्यादा से ज्यादा 3, less or equal to, less or equal to 3 का मतलब है probability of 0, 1, 2, 3. e minus 1.2 की पावर 0 अपॉन 0 फैक्टोरियल प्लस e minus 1.2 की पावर 1 अपॉन 1 फैक्टोरियल e minus 1.2 की पावर स्क्वायर अपॉन 2 फैक्टोरियल e minus 1.2 की पावर क्यूब अपॉन 3 फैक्टोरियल। फाइनल आंसर बता रहे कोई? 0.966।